Okay, hi Ahmad. Since I thought we may not meet soon, I thought I'd create a video so I could explain this to you. I just made a snap of the quiz question. I did this, and it's changing all the time, so um, you may not get the same exact numbers. Now, you want to suppose a binary search tree was built by inserting the following ints. Now, you should remember that if you want to create, let me just change the color this so you could see better. Thickness, all right. Now you have 4, 6, 8, 5, 2, 1, 3, and 7. Just remember, you put the first number, whatever is lower, you put it on the left, lower, and whatever is bigger than that number, you put it on the right. This is how the binary search tree works. Okay, now the first number is 4. Now I'll put it here. The second number is 6. Is 6 bigger than 4 or smaller, lower than 4? It's bigger, so I'll put it here on the right. Now the next number, 8. Is it bigger than 4 or lower? If it's bigger, it goes to the right. Yes, it's bigger. Okay, I get 6. Is 8 bigger than 6 or lower than 6? It's bigger, so it goes on the right. There's 8. Now, next number, 5. Is 5 bigger than 4? Yes. Is it bigger than 6? No. I'll put it on the left. 5. Now, number 2. Is it bigger than 4? No. It goes on the left. Number 1. Is it bigger than 4? No. Is it bigger than 2? No. So I'll put it on the left. Number 3. Is 3 bigger than 4? No. Is it bigger than 2? Yes. I put it here. Number 7. Is it bigger than 4? Yes. Bigger than 6? Yes. Bigger than 8? No. I'll put it here. Okay. So I got all numbers here. Now what is it asking me? The left-right links for the node with 4 in it. Point 2, write a 2-word list. Each word should be an int or null. Okay, what does that mean? Let me change this to red. Okay, null means I draw a line here. There's nothing in here. So this becomes null. And if I have a 3, for example, here, then I put the 3 here. And remember, null, write a 2-word list. It means, so there are 2 stemming from this number, right? So I should have a number and then another number. So the number here is null and the number here is 3. So I just gave you that for as an example. Let me just erase that and get back to the question that we had. All right. So we're looking for number 4. Okay, this is our number 4. What's on the left? It's a 2. What's on the right? It's a 6. So this is the 2-word, and he says that we have to put like 1 space. So let's check if it's correct or not. Yes, that was correct. So 2 and 6 are the numbers that coming from node 4. Now for next question, the left-right links for the node with 6 in it. Just it's recording. Yeah, it is. Write a 2-word list. Each word should be an int or null. Okay, now we're talking about 6 here now. So left is 5. Right is 8. So I have a 5 space 8. Let's check if that's correct or not. It is correct. All right, so these are fairly easy. Now we get to here. If you remember, he had a website, and I'm in the binary search tree folder 10 a.m. binary search tree.java file. Now remember, these are the important things. So this is in the file that we worked in. So in order returns a string which results in an order traversal. In order traversal means you first write the left, then you write the node, and then right. Post order, left, right, node. Pre-order, node, left, right. This is how you write the items. Now let's see what he's asking us. Now the result of pre-order and here post order. Let's get back there to see what is pre-order. Pre-order is this one. So node, left, right. Node, left, right. So you remember, these are called nodes. When you have branches, that item, that number becomes the, so sometimes in class we practice with name of the students. So it could be words. So the item that you have here is called the node. Now, node, left, right. So the first item is 4. That's our node. Left. This is the left, and it's a node. So we write it. Then, okay, sorry. It's my son bars in. Okay, let me delete this from the video. All right, then the next item is so we have 4. The next item is, this is the node. Now again, I go to the left. That's the 1. It's not a node, it's one of the leaves. So if there's nothing below that, I write that down. Now there is nothing here. I have to go back. This is the node. I already wrote that down. So I go to right. See, we have to do the right thing. So this is 3. I write that. Now, is there any item here? No. I go back. I already mentioned the node. I go to the next node, 6. I write it down. It's one of the nodes. Again, I go to the left. 5. Then there's nothing here, so I have to go back. I've already wrote that down. I'll go to the next node. Okay, that's 8. I write that down. And then I go to the left. I write 7. Is there anything here? No. So nothing wrong. This is the answer. So let's just check that. 4, 2, 1, 3, 6, 5, 8, 7. So that's the correct answer. Now for the post order, let's go back here. Post order. We write the left item first, right item first, and then node. So left, right, node. Left, right, node. Okay. Now let's do this again. Get rid of these things. Right. So left, right, node. Let's do it. 4 is a node. We don't write it. 2 is a node. We don't write it. We go left still. 1 is not a node. That's like the last leaf. So we write it, and it's on the left. So we write 1. Now, then right. So we go back. There's nothing here. We go back. It's a node. We go to the right. 3. Is there anything here? Nothing left there. So we write that down. 3. Now we go back. We have written left and right. So now we can write the node. 2. So 2 is a node, but compared to 4, it's a leaf. So we don't write the node. We go back to the right. But this right already has leaves. So we go to the left. We have 5. 5. There's no leaves here, so we write that down. We go to the nod. We don't write it. We go to the right now. Right. 8, but it has leaves, so we don't write it. We go down to the left. We have a 7. There's nothing below that. We write it down. Now we go back here. 8. You should go to the right since right is null. There's nothing here. Null means nothing. So we don't write that. So we can now write the nod. 8. Now we go back. We have already written the 5. So now we can write down the nod. 6. Now we have already written the left side, right side. Now we go back to the nod, and that would be 4. So let's check if that's the correct answer. 13257,864, which is correct. So basically, you have to know how this works, and you can apply it to the other questions, because just remember it changes all the time. So first time I thought I got the answer from the board, and it was not like that. So I got like, let me go back here.